This is a comic book in Chinese that my daughter really likes, but there's a lot of vocabulary in here that she doesn't know. So the objective of this project is to turn this book into teaching materials. So the first part is just a repeat of the story, and what we've done is used large language models to extract the script and the vocabulary, and of course match it with a simplified English meaning that kids would understand. There's pages of that, and then we've got a whole page of reference vocabulary that can be used to populate these blanks within these sentences. Pages of that. And then this is a second exercise where the child has to match up the Chinese vocabulary with its corresponding English meaning. And we've got a few pages of that. And then this one, they have to take a sentence that's been chopped up into fragments and jumbled up and turn it back into a complete sentence. And there are 2 pages of that. So this repository is not as self-explanatory as I would like. So I did a little diagram just so that you can see what all the pieces do before we dive into the code. So you know how all the pieces come together. So if we just zoom in here for a bit, at the beginning there are 2 inputs. The first input is a set of images which represent pages of a comic book. So I just scan these in. This is an example of and they're all named 1.png, 2.png. That just makes it easier for the code to loop through. And so in this particular story, there are 9 pages. And then inside main.py is a little section to input configuration variables. And so, for example, if this is lesson number 1, this is story number 1 in the book, this is just used for the PowerPoint file naming. This is used in the directory path. So if you put in 1 or 2, then you need to look in the right directory path for all of the files that will come later. And then the title and the subtitle, that will go onto the title slides. And num images, that's just the number of images that you're inputting. That just is for looping. Okay, so all that stuff gets put into a large language model. And in this particular case, I decided to use the OpenAI API O1 model. And this is one of their most powerful reasoning models. I would have liked to use the O3 mini model that just came out, which is way cheaper, but apparently it currently does not support images. So that's why I had to use this one. I was going to try using the O1 mini to see if it does as well. But even with the O1, which is the most powerful one and the most expensive one that they have, these JSON files are still, only 95% there. It needs a little bit of adjustment. So I didn't want to create even more work for us humans. The other thing that you'll see as input into the API request is the prompt. So this is just a bunch of text explaining to the model what we want done. And the other important thing is this is a JSON schema to define how we want the information to be output. And so we're calling this model in a JSON output request mode as opposed to text mode. And so just as a little, you can go into the code to look at this, but the prompt right now is something like this. I'm going to give you a page from the Doraemon comic book in Chinese. I want you to extract the text out in the form of a script and to highlight the vocabulary. Make sure the pages are processed in the right sequence, and it should be right to left, blah, blah, blah. And then the script text should be like this, annotated with the name of the speaker, colon, and you should extract from 0 to 2 vocabulary from the script text. Blah, blah. And then it just basically reminds it that we want it output in this kind of JSON format. So for every line that is spoken, so for example, this is one line, we want it like this. So the key is script text, and then whoever said it, and this is what they said. And then the vocabulary is like any words in here that a child might not know. So this is, in Chinese, we have 2 versions, like simplified and traditional. So this has both, and sometimes it looks the same and sometimes it's different. And then the corresponding English meaning. And so this object would be correspond to 1 line in the comic. And then the JSON schema. So this is there's a certain format to writing this kind of thing, but basically I'm just saying I want at the top level I want something called a script list. So this is just like an array. What else have I asked for? Oh, and then inside the list is an array of objects, and each object is basically what I showed you. It includes a script text and then a vocabulary. And then the vocabulary is an array because there might be more than 1 vocabulary within each line of text. All right, zoom out a bit. All right, so we use all that, stick it into the model, and what we're basically doing is rather than giving it all the images all at once and then spitting out one file, we're just doing one image in, one image out, one image in, one image out, just because it's, I think it sometimes can get really confused if we give it too much. And it also makes it easy for us to do the human check after this stage. So it spits out each of these files, one, oops, that's a mistake, one corresponding to each image. And then here we have applied like a human review gate just to make sure that everything looks good before it goes on to the next stage. And I think at this point of these models' maturity, sometimes it will get things like this wrong. So for example, within this box, there's this and this. Sometimes it'll put this above this, when in fact should be this above this. So sometimes the sequencing needs adjusting. And the other thing that needs a little bit of like a teacher input is what constitute as a vocabulary for the child that is learning this, right? So the teacher will know something about the level of the child, and so some of the vocab that is extracted by the LLM is actually too easy for the kids, so just delete it. And if there's something that we want to add, then we can add that. And later on, I'll show you how I use GitHub Copilot to make this whole process much faster. Okay, so after the person has reviewed, just to avoid, if we rerun the code from overwriting the human effort, we will copy these post-review files into a separate folder called final_JSON folder. So sometimes, you might want to rerun this part for whatever reason. You don't want that to be overwriting the files that you've already edited. Okay, so here we have a bunch of post-review JSON files. What we want to do is we don't want it as like 9 separate files. We want to just concatenate all of them into a single file. So we just run it through some traditional Python, put it into a single JSON file, and we call this the aggregated script JSON. And at this stage, this is fine. This contains all the information that we need. But for some of the slides that we're trying to generate, it would be easier to generate it if the data was formatted in a certain way. And also, there's just way too much information in here, so we want to deduplicate, and we also want to filter out some things that are maybe not suitable for that particular exercise. So for example, for FITB stands for fill in the blank. So this is where we take a sentence from the script, we mask out the the vocab, and then make the kid fill it in. And for this kind of exercise, we have so many sentences in here. We don't want to use every single sentence for this exercise. So we will do some filtering here of the sentences that are too short and not that meaningful to create a subset. And also we will deduplicate the vocabulary just to make sure we don't have anything that's not necessary there. And then at this stage, we will have 2 more JSON files. And you'll see it's just formatted a little bit differently. So here we have a vocab list, and we have the key, we have the vocabulary as the key, and then the value is an object that contains simplified Chinese, traditional Chinese, and English meaning. And we do this, we use the vocab as the key just as a method of deduplicating. And then here, FITB, so it looks something like this. There's a sentence which has the vocab masked out. It has the complete sentence, which is like, a reference for the teacher or the parent. And then the vocab, the correct answer that should go in here is here. And right, so at this human review stage, the other thing that we need to do is there's also a type of exercise in the PowerPoint deck which involves a jumbled sentence, like a sentence that's broken up into fragments and jumbled, and then the kid needs to reorder and piece that sentence back together. And not every sentence is really appropriate for that kind of exercise. And in our deck, we only want 10 of these sentences. So here, instead of trying to use AI to do it, which would be kind of complicated, we just have the human go into the FITB file and to add this thing seg :true for to around 10 sentences in the document where we want to use for the unjumbling sentences exercise. Oops. All right, so after these files are ready, we're ready to create the deck. And as a input into the deck creation process, we use a PowerPoint template that's been designed in advance. And you'll see here, I'll take you through it in a bit, but for each type of slide, we will have one template. And then these are our placeholders. So you'll see at this point, this is all duplicated. And this is also where we apply the font styles. So you'll see in this template, these Chinese words have the phonetics on top, and these Chinese words have the phonetic on the side. So this is just a special type of font. And so it is at the design of the PowerPoint template that we put in this, and that's not in the code itself. And I guess, there are some slide generators out there that makes this whole thing more AI based, but because I want very precise control over how things look and where exactly things go, that's why we've decided to do it this way. And you'll also see in the code that there's a function which is optional. It's really just for myself, for the developer, um, to take the template and to populate them with the index number. So PowerPoint is really weird. Like when you start creating these placeholder text boxes, for some reason it starts with an index of 13, and then of course each box has a reference number. So the code somehow needs to know where to put things, and you need to know which box corresponds to which number. And so I've got a bit of code here that just takes the template, um, populates all the placeholders with the number, and this helps with the coding bit. Yeah, unless you're messing around with the template, you don't really need to use that. Right, so we take the PowerPoint template, we take these two files, and also this one. So we feed it into just a traditional Python library uh, to place all of this data into the right place in the template, create the correct number of slides per template, and then and output a PowerPoint file. Let's have a look at the PowerPoint template and how to put that together. So right now I'm inside Microsoft PowerPoint, and when you open up the Doraemon lesson template v1 file, you'll see something like this. It looks like it hasn't got any slides in there. That's because this is a PowerPoint template. To see the template, you need to go to View, Master, Slide Master. And here you'll see all the different designs that we have for slides that we're going to be generating. So here we have a title slide. This says teacher version, and then this has the title and subtitle. These are placeholders. So these will have a number reference to them that the code can reference to say, oh, I want to put this bit of text in location 13 and 14. So that's another one. This is the one where we're going to put the script and then the vocab. So you can see it all has to be kind of laid out manually if we want this like precise control. And you can also see here, let me see if I can zoom in a bit. These words have a little like phonetic thing on top. This is like a special font type that's used for Chinese learners, and we also specify this inside the template. And this is yet another font that supports a different kind of phonetic system. So if you opened up this file on your computer and you don't have these fonts installed, you might see something a little bit weird. Okay. So this one is where we have the big collection of vocabulary to choose from, and you can also see that here we've got 30 placeholders. And part of what makes the code a little bit messy is if we have less than 30 vocab, then we still need to loop through the remaining placeholders to just put a blank in there, so it's not showing these duplicate placeholders. This one is for the fill in the blanks sentences. This one is at the beginning of the deck. You'll see that we have those comics. We're basically just dropping the images into the PowerPoint. So this is the slide template for that. This one is the matching. So the English matching with the Chinese words. Yep, so that's what a template looks like. Oh, you can also see that here, just to shake it up a little bit, these three slides have the same functionality, but they just look a little bit different. And so in the code, we just loop through so it looks like it's less machine produced. So that's what a template looks like. Now let me show you what the index file looks like. So the index file, you will actually see these as slides, and it'll show you like, oh, this placement is number 13, this placement is number 14, and then this one is like this is 13, 14, 15, 16, and then these are 20, 21, 22, 23. So actually the way in which I did this made the code more messy than it needed to be. I should have gone sideways like this as opposed to going down like this. So in the code you'll see a bunch of offsets. That's really just trying to get the right things in the right places. I have no idea why it starts at 13. If anyone does, let me know. So now we are in GitHub, and I'm just gonna navigate you through the repository that I've made public. So you can clone it and play with it. There are a couple of key files. This README is where you should start. I tried to document a little bit, like what, how to use it and all the different steps and the commands that you need to run to do each of the steps. And main is the key file that calls all the other functions. And then requirements.txt is the dependencies. And then utils, blah, 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 utils, blah, 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 are just submodules that are pulled in by main to do its magic. Some of these are I'll be deleting. It's not relevant for this project. All right, so let's look at this folder called Doraemon content. And so every time you are producing a new lesson, it will be a new story. And inside each, let's look at story 2. Inside each story would be 3 folders. The first one is images. So this is where you should stick all your comic pictures in. Okay? So the script will pull from this folder. Okay? And then after we feed those images into the large language model, the output that it generates will be here. So this is like the raw data that's been output from the large language model. You'll see that it has turned that image into a line of script, like who said it, what he said, and in some cases these words are so easy that there's no vocabulary, and then others you'll see, oh, it extracted 无聊, like this one, and it means bored. So later on I'll go into the VS Studio Code IDE to show you one of the tricks that I use to edit this file as a human teacher. What else can I show you? So the final everything that the machine generates will be dumped into this folder. Anything that's like post human edit should be moved to this folder, just so the machine doesn't overwrite these files. So these just look the same, but this had a little bit of editing done to it. And in the diagram, you'll see there's a part where we concatenate all of these into a big file. So that's just this one. You'll see it looks pretty much the same, but it's like a JSON file with the title, subtitle that's used for populating the title slides, and then the script list, which is a huge concatenation of all the content in here. And then these two are the kind of the sub files, which are filtered and reformatted versions of the data that comes from here. And you'll also see that this bit is human added because we only need 10 sentences for the segment unjumbling exercise, and not all the sentences are really suitable for unjumbling, so it needs a little bit of a human input there. So and also there's just way too many sentences here. There's like 40 something sentences, and we only need 10. So basically a human will copy this and then just go down the sentences and just paste it where they think the sentence is suitable, and just do around 10 of them. And this needs very little intervention. And then yeah, so all of those files then get fed into these PowerPoint templates. So you'll see this one is the one that I showed you just now, and then this one is the one with the index. This is for human use, really. So the combination of this and the data in here creates this output, which is the end product, which you can't really see here. The other thing that I should call your attention to is the prompt template. And you could stick it in the code, but just to make it a little bit nicer, I extracted it out here. So this is just the prompting that we're feeding into a large language model, and we also provided it with an example of the output that we want. And we are also calling, let me show you here. Yes, it's ask image GPT, and we are feeding it in we have the text prompt, and we have an image. It says image URL, but actually we're feeding it a base64 binary file, which we're pulling from that folder that I showed just now. And you also see this thing called response format equals target format. So let's have a look at what is target format. Target format is basically pulling in the response format file in as JSON and then feeding it to the OpenAI API endpoint. And the response format file is this one. So this just explain in a rather complicated way the format that we want, which is in reality not that complicated. Oh, let me walk you through the README. Okay. So first step is you clone it to your local machine, and then you set up your virtual environment by typing in, opening up terminal, navigating to the project directory, and then typing in these commands. This just makes sure that the packages that you install is isolated from everything else that's in your computer system. And then after you're done with everything, just type deactivate to get out of it. And the next step is you need to install the libraries. So just to make it easy for you, I've already put in all of the requirements in requirements.txt. So you just need to do pip install requirements.txt to install all that stuff. And then of course I did not include the API key inside the code. This needs to sit in the environment variable inside whatever machine you're using to run this. And one of the ways that you can use if you're just running off a laptop or something is you can put a .env file in your root directory and just put in your keys there. Because what the code does is to look for environment variables, and if it cannot find, it will also look inside this file. So that creates a bit of flexibility about, on your local machine, it's pulling from the .env file. If once it's pushed to the server, then it's pulling from the server's environment variables. And then step-by-step instructions are in main.py, but here's an explanation. So running the code, step 0 is optional. If you run this command, it basically takes the PowerPoint template that I showed you and then creates the one with all the index numbers. And that really is not within the workflow at all. This is just for development purposes. So really where we start is step 1, which is you run python main.py -- image to JSON. So this loops through all of your 9 images one by one and creates the JSON file. And then after it's done that, then you should review it. So this step 2 is a teacher in the loop. Once you've approved it, edited, move it into the LLM final folder. And then step 3 is concatenating all the JSON files into a single file. And so just run this command to do that. And step 4 is it reformats and filters the aggregated script file into 2 additional files, like these 2. So you just run this command. And then here's another teacher in the loop step. So you do all the things that I described just now, and then move and rename the final documents into final JSON folder. So step 6, it pulls everything from the final JSON folder and uses the PowerPoint template. Run python main.py -- create final deck to create the final deck, and then it will sit in the output lesson folder. That's it. And the final bit that I was going to show you is how to edit the JSON file and how to use Copilot to assist with that. Alright, so now I am inside Visual Studio Code IDE. So this is where I do the coding, and I just wanted to show you, okay, right now I'm in the story 1 folder, and inside this LLM JSON file, I have these raw JSON files that came back from the large language model. So here, let's say, there's a vocabulary that's so here there's another, it selected this word as a vocab, but I think also the child might not know this one. So I want to create a second vocab object. Look at that. Like, it already can guess which one I thought I wanted and fill in everything. That's just amazing. And then now it's guessing a third one. No, I don't need a third one. That's just amazing. Let's see, I switched to another file to see if there's anything else. Oh, here. 一整页. So let's just say it cannot guess what I wanted. So I'm typing the SC vocab and I'm putting it in here. And now I want the other things, right? But I don't want to type it. Look at that. It already did it. So I just press tab, and it's already done. That's so amazing. So here in this project, we're using 2 types of AI models. It's the OpenAI O1 model, and here we're using GitHub Copilot to assist us with the human editing.